So now I'm going to talk about the circuit breaker closing circuit. All right, what is it saying to you now after all the effort we've put in? In the end, here is the positive coming to me like this, right? This is the positive, okay? And here I have a contact coming to you from the zone. What's it called? It's called K11. In the end, K11 represents the close command, the final closing command you have. Is that clear? You said excellent. All right, now it's telling you to focus with me very well. It's saying that now you have, as I go along with you, here at the end, something called the auxiliary, or the solenoid or the coil of the circuit breaker closing. So what is this closing? The closing coil, is that clear? And what is supposed to be connected to the closing coil in the end? It should be connected to a neutral. Now, elevate your imagination a bit with me and consider this as all the connections leading to one point. Now, the cross command is closed here. Okay, as soon as the cross command is closed here, the positive is connected to the cross coil and the negative is connected to the cross coil. So the breaker is supposed to close, right? You told me yes, but still, there's something. What do you want? There's something that needs to be determined first. What is it that you need to determine first? Now, it tells you what? It tells you that now, if you come to give a close command and the breaker is actually open, the breaker is indeed open. That's good. Okay, if the breaker is open and you come to give a close command, all right, that's good. And if the spring of your circuit breaker, or let me put it to you in another way, better. All right, fine. Let me put it to you in another way or with another arrangement. I have a better arrangement now. I gave a close command to the breaker. If the breaker is originally open, what will happen to the breaker? It will close. Okay? If the breaker is closed, engineer, if the breaker is closed, what will happen? I mean, if the breaker is already accepted and you come and give me another close command, what will happen? The positive will go to the closing coil and the negative will go to the closing coil, right or wrong? And I think that's right. Okay, do you have a problem with the breaker being closed? Of course, I don't have any problem with the breaker being closed. But this coil, engineers, is part of a system we call heavy duty. What does heavy duty mean? It means this coil is like the motors we used to study in college. In the specifications course or things like that, they would tell you that motors come in S1, S2, S3 up to S9. They would tell you continuous time duty, short time duty, and so on. The closing coil is short time duty. What does short time duty mean? It means that when you apply a supply to the closed coil, it draws a very high current to be able to release the spring mechanism for closing the breaker. Especially since it is heavy, it needs a very strong force to lift the solenoid so that the closing coil can move. For this to happen, the closing coil draws about 6 to approximately 10 amperes. If this current is drawn for more than 5 seconds, the closing coil will move. All right, if you are playing around and keep pressing, giving the operator who is not paying attention the command to close, 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 while the breaker is actually closed. Will the breaker close? No, the breaker will not close, right? It's a mistake for the mechanics, it is closed. But this action will cause the breaker to draw the current that you mentioned, especially if he presses, not closes. He should press properly, hold his hand like this for 2 seconds, and then remove it, of course, in close intervals. Naturally, it will burn out after 10 or 20 years if he keeps pressing and releasing in close intervals, pressing with the hand for a second or two. You'll find that your cross quad is burned. So what do we do here? We come here and take a contact from the circuit breaker itself, which we call 52A. The term 52A is not for engineers. Firstly, this number is always something called the ANSI code. The ANSI code. Exactly. What is it or what does it explain to you? 52 means circuit breaker. And what does it mean? Normally open contact. All right. This means a normally open contact from the breaker. So what is this normally open contact related to? Well, the breaker is always depicted in my drawing as being in the open position. So this contact is open. As long as the contact is open, as long as the breaker is open. Yes. So we gentlemen, 52B. Close 52B. What? Normally closed. Contact. Normally closed. 52B. This normally closed contact, as long as the breaker is open, it remains normally closed. What is its purpose? Its purpose is that when I give a close command and the breaker is indeed open, the positive will go to the close coil, so the breaker closes. Just as the breaker closes, this contact will open again. So if this contact opens, even if you give the close command again, the DC will not reach the closing. To the closing coil, and this is what we call the anti-slam. The anti-what? The anti-slam. Okay, so the anti-slam engineers, what is it exactly? It is a normally closed contact from the circuit breaker, which is 52B, placed in series with the closing coil to inhibit it. This is to prevent you from giving a second close command to the circuit breaker if the circuit breaker is already closed, to prevent the coil from burning out. From burning out because it cannot draw that current for a long period, more than 5 seconds, it will burn out. Oh, exactly. Okay, great. Now, moving on, here we also find another contact from the spring, charged spring, exactly charged. Normally open or normally closed is taken here as normally closed, okay? If the spring is charged, you find this contact closed. If the spring is charged, what do you find? Open. So why is this not present now? If you give a close command and your spring is not charged, what will happen? The positive will go to the closing. Clear, the breaker is already open. The breaker is open. The current goes to the closing coil. The closing coil is drawing current. But does the breaker close? No. Why? Because the spring is not charged. Now, can't this burn the coil or not? It can burn it. That's why I put a normally closed contact to handle the spring state. So what is the natural state of the spring in the scheme? Its natural state in the scheme is discharged. As long as it is discharged, what is its contact? Its contact remains open, right? Am I wrong? Normally open. So as soon as the spring is charged, this contact closes. When this contact closes, it allows you to close the what? It allows you to close the circuit breaker, right? Or am I wrong? You told me right. So you have something else. Now let's see something else. Now we want to understand what anti-pumping is. What is this anti-pumping, Engineer Rashid? Let's understand it together. Now if you send a close command here to the breaker, so this contact closed, and for some reason known only to God, you did what? You kept your hand on the command, meaning you are giving a close command. You pressed and held the close, or when you gave a close command from the PCU, its contact remained latched and didn't change. No. Meaning it didn't open again and remained in place. Sometimes this happens with relays, especially relays where you find the contact closed and didn't open again. Or the contactor itself, its contact got stuck or burned. So the contact remained what? It remained touching each other. So now if you give the close command here, what happens to the breaker? The breaker will close. But doesn't this contact open after the breaker closes? You told me yes, even if this contact open, even if this contact is still stuck or still pressed or still closed, there is no DC going to the closing coil, so you don't have a problem. I told you right up to this point, you don't have a problem, but suppose after that you came and opened the breaker, or let's say when you closed the breaker opened again. You encountered a fault on your line. So what will happen? As soon as the breaker opens again, what happens to this contact? It returns again. So as soon as it returns, did you remove your hand from here? Did this contact open? No, because this contact is stuck. Immediately this pin goes back into the close coil, causing the breaker to trip and close again. Okay, the breaker closed, but the fault is still present. So what happens to the breaker? It opens. It finds a close command in front of it. So it closes again, then finds the fault and opens again, finds a close command in front of it and closes again. How often does this happen? Every 10 seconds or so. Why every 10 seconds? Because when you close the breaker, the spring takes about 10 seconds to recharge. So even if the breaker opens and the DC is present here, what happens to this contact? It disconnects the circuit. After 10 seconds, this contact recharges, connecting the breaker, so the breaker closes. After the breaker closes, it finds a fault, so the breaker opens. As soon as the breaker opens, it finds the breaker, so the breaker closed and opened again. but the spring is recharging. After it finishes recharging, it closes and opens. Then the spring recharges, closes, opens, and so on. So what is the danger in what I'm telling you? There are several dangers. The first danger is that now you are repeatedly closing and opening the breaker on a fault. This means you are continuously closing and opening it. And what happens between the poles? There is an arc forming between them, right or wrong. This way, your poles will get damaged. The second issue is that this process repeats every 10 seconds, meaning every minute you will have 12 operations, 6 closes and 6 opens. So if the operator responsible for this station takes half an hour or an hour to reach the station or to address the problem, imagine an hour. That means you have 60 times 12, which equals 720 operations happening where? In the circuit breaker. So of course, mechanically, this is wrong mechanically and electrically due to the presence of the arc. This is incorrect. In addition to the frequent arcing every 10 seconds, the SF6 gas will naturally start to heat up and decompose. So, of course, you're not giving it a chance to happen again. The SF6 gas might lose its insulating properties. So what am I going to do to solve this problem? They said it's very simple. And inside itself, they brought me here like this. All right. They isolated it for me and named it, for example, Y, or any nice name like that. And what did they do? They came here like this, all right, and took contact 52A. It was 52A. 52A from the circuit breaker status, all right? They took this 52A here and used it to operate the auxiliary, which is also connected to your same negative, all right? Connected to your same negative. Nice, guys, good. So what next, engineer? Let this connect to what on the negative? What? All right, now as soon as you give the close command and the close reaches the breaker, as soon as the breaker closes, this opens. And what's with this? This closes, activating the Y. When the Y is activated, you take from it here a normally closed contact from this Y here. All right, what's it called? It's also called YB, okay? A normally closed contact. What's its purpose? Its purpose is to open the circuit here. Therefore, if you give a close command, as soon as the breaker closes, this closes and this opens. So it activates and opens the path here. As soon as the path is opened here, if the breaker trips again, what will happen? The breaker tripped, this contact will return to close again, and this will return to open, so it will drop off. Then you'll find there's a close command sent again. That's why the contact or the component called Y, I will use it to self-latch itself. What is Y? So how will the process go? Let's focus. I gave the close command, the breaker closed, this one opened, and this one closed. When this one closed, it activated Y. As soon as Y was activated, it latched itself. It closed this, creating a latch on itself in this manner. So now its contact is open, meaning even if the breaker opens again, this contact returns to being closed like before. The positive will go down, 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 and find this contact open in its path. This is what we call net anti-pumping. I will prevent the breaker from closing again after it opens. If the close command is stuck or continuously active due to an issue, for example, with the contact in the auxiliary, or a problem with the contact coming from the PCU, or whatever the case may be. The important thing is to protect the mechanism of the circuit breaker from getting damaged and to prevent the arc that would occur every 10 seconds or so on the poles, which could cause the breaker to explode and the SF6 gas to lose its insulation properties. This is what we call the anti-pumping feature. All right, guys, very good. So what else did we say? We mentioned something very simple, or actually two very simple things. I will focus on just one of them, which is the SF6 gas. The SF6 gas pressure is supposed to be healthy, or in other words, the engineer, I think it was Fad, or I'm not sure who asked me this question yesterday, when he was saying whether the SF6 gas pressure only gives a warning or performs a specific action. So the idea here is that when the SF6 is healthy, the engineer ensures that as long as the SF6 gas pressure is healthy, this contact remains closed to allow the breaker to close. If it drops to a low stage, stage 1, meaning the first stage, if it drops to stage 1, this contact opens, preventing the circuit breaker from closing. as long as the gas pressure is below the permissible pressure for closing the circuit breaker, which was approximately, we were talking about 550. All right, we're not forgetting where we are here. This is the lower gas pressure, 6,550, and the low stage 2 was, for me, 500, just like that. Nice, this is regarding the circuit breaker, so I'll come here again. Here's the circuit, my circuit breaker. Of course, here's K11 that you saw. Here's the normally closed contact, which is 52B, and here's the normally open contact, which is 52A. You come down here, it gives the close command to the breaker, pip pip. Never mind the naming, I named it CY. The Y1 here is not important. This is the closing coil of the breaker. Nice. You'll come down here and find K17, K16, K84, and many other numbers like that. All right, so who is K17? Here it is. You see the normally open contact. Wasn't it supposed to activate the anti-bombing relay? The anti-bombing relay is called K17, and it's supposed to latch onto itself. Here it is, latching onto itself, so it latches onto itself, and I take from it a normally closed contact. What do I do with it? I use it to prevent the breaker from closing again. All right? Okay, and who is K16? Let's go back in memory to yesterday. We'll remember that K16 was the one handling what? It was handling the spring or the spring flow condition you have, meaning it's not charged. So K16 was operating. So when the switch operates, it opens the collagen, preventing the negative from passing below to reach where? That's the collagen. Okay, and who is K84? K84 is the SF6 gas pressure. How do we know? Let's see here together the gas pressure. Okay, and who is K211? It has no purpose. But okay, let it be there. K219 tells you something called a double command, which you'll understand with me tomorrow. Just ignore it for now. Consider it as if it's not there. Who is K84? K84 is not present. What is it? Come take a look with me. You have the gas or your gauge, which has 3 contacts, a contact specific to it, a contact specific to low stage 1, a contact specific to low stage 2, and a contact specific to the high stage. All right, the contact specific to low stage 1, the contact specific to low stage 2, and the contact specific to the high stage. As I told you, low stage 1, you'll find it as contact numbers 1, 2, 3, and 4. Low stage 2 and the high stage are 5, 5, and 6. All right, under normal and expected conditions, if the gas pressure is in a healthy and stable state, what do you typically find happening, engineer? You find that contact 3, which is present in the gas meter, whether it's a Wika or any type from Germany or any other type you have. This contact is closed, engineer. Closed as expected. In the healthy condition, everything is completely closed. So how does the situation proceed, gentlemen? Now you have the positive coming here from above and the negative coming here from below. Here is a timer, but this time, engineers, it is an off-delay timer. Okay, how did you know from me, Engineer Rashid, that this is an off-delay timer? Let me tell you how I knew, or as an engineer, the off-delay timer is always connected to both the positive and negative. Unlike the on-delay timer from yesterday, the on-delay timer here would have the negative with the positive cutoff by a certain mechanism. However, the off-delay, and of course, if you refer to the bill of materials, you will understand that it is indeed an off-delay, but it is always connected to both the positive and negative. It has a signal here that comes between 2 other terminals. This signal comes from a normally closed contact, giving it a closed signal here. This timer is always in off-delay mode. What does off-delay mean? Off-delay means exactly like this. This is its diagram. You have something like this, let's say it like this. So now you have the timer. As soon as this signal reaches it, the timer immediately changes the states of its contacts. Normally open becomes closed and closed becomes open. As soon as this signal is removed, meaning if this contact opens, from that moment, it starts counting the time you set for it. Then it returns the states of its contacts to their natural state. All right, great. This is what the on and off are for. And of course, if any of you have worked with it before or worked with any device, you will understand what this means. Okay, so you have it quite simply. Of course, you will understand it even if you are in a situation where you don't have to use it, but you will still use it. We always use this inside. Okay, so now if the gas pressure is correct, this timer changes the positions of its contacts. And here as well, it changes the positions of its contacts. We agreed that a breaker has two gauges, right? So you have this as gauge 1 and this as gauge 2. This contact is closed and this contact is closed. So this timer is working and this timer is working. It's working but hasn't started counting time yet, and it changes the positions of its contacts. Now the contacts here, Mr. Engineer, are as follows. Here are the contacts of the first timer, which is T5, and here are the contacts of the timer named T6. So now these timers will open this contact and open this contact. So both of them are open. Therefore, the auxiliary contact below is disabled or dropped off. Let's say dropped off. All right. As long as they are dropped off, the contact drawn here, we always know that all the auxiliaries, the contact at that time is drawn as dropped off. So it is normally closed, okay? When the gas pressure decreases, this contact immediately opens and that contact opens. So the timer here starts counting 5 seconds. Once it confirms that this is indeed correct, it returns this contact to its normal state again, which is normally closed. All right, when it returns to normally closed, who does it activate? It activates the observe release. And when the observe release is activated, this contact of the relay opens, preventing the breaker from closing or operating. Is it clear now, engineers? Good. First of all, and finally, who do you have here? You have DC supervision, just like what was present in the AC circuit, or the IO circuit, or my motor circuit. So now we have completed the closing circuit for whom? For the circuit breaker. All right. Did any of you feel that I could specify it? You could write it for me in the chat or something. One of you could tell me, Engineer Rashad, excuse me, but you told us about pumping. And you told me that if I dialed the cruise command and the video was stuck and the breaker was closed and due to a malfunction it was opened, then the cruise command must still be stuck. So as soon as the spring is charged, you will give it another cruise. God, you were just a while ago staring at us and you took us to page 20A and you kept telling me to look out really. And what you said, what did you express? Confused? I'll tell you, look, I can answer in 2 ways. The first way is that the breaker factory doesn't know whether you will use it at station 94 or 86, right? Or am I wrong? So you are using 94. And as soon as the breaker opens, there is no closed block, meaning there is nothing to prevent the closing process. The second thing is, let's say the issue occurred in the contact itself, which is K11, the auxiliary contact. If this contact remains closed, regardless of the protection preventing it, you still have it closed. So it will directly go to the closed coil. Who will protect the breaker from repeated opening and closing operations during the hour, which can reach up to 720 times, in addition to the arc that will occur while the breaker is opening? How could this damage my circuit breaker? Is that clear? Good. Okay.